The auto shop problem is a break-even problem. The first half of this two-part problem is actually a straight application of the break-even formula. Let's take a look. AutoShop is considering the purchase of a new engine computer code reader for $65,000. That is a classic example of a fixed cost. The outright purchase price on some asset. AutoShop can charge $75 for the service of reading the codes. That is the revenue per unit of production, while the actual cost of reading would only be, $10 per engine. Good description of a variable cost. So there we have right there inside of those two sentences each of the three parameters that we need for the break-even formula. Now if you look at part A, it asks for the break-even formula by name. For how many cars would AutoShop need to read engine computer codes to break even on this purchase? The quantity to break even is the fixed cost divided by the revenue per unit minus the variable cost. Oh, so we just need to fill in from here. Let's see. In the case of AutoShop, they're going to put down $65,000 to buy that computer code reader. They can charge $75 for each computer code that they read. That's R minus, it does cost them $10 to do the reading. Oh, okay, so this winds up being 65,000 divided by 65. Oh, comes out nice and neat. 1,000. 1,000 what? 1,000 readings. What's that mean? It means that in order to pay for the $65,000 computer code reader, AutoShop needs to read 1,000 computer codes at $75 a piece. All right, now that's just application of the break-even formula. That will cover their costs. The second part of this problem is also an application of the formula, but it's a little more indirect. Let's take a look at it. Suppose that the manager of AutoShop is concerned about this purchase and has stated that if AutoShop were to buy the new engine computer code reader, the machine needs to pay for itself. That is another phrase for break even by the time we use it to read 200 car engines. The manager says this is because this sort of computer code reader goes out of date very quickly, so if we don't get our money back soon, we will probably just wind up replacing the machine before it ever breaks even. What would AutoShop need to charge for the service? What would they need to charge for the service in order to break even? Oh, this is a classic example of a question in which you have the answer that a formula gives you. What you're being asked about, what is it that we're looking for? How much should they charge? If we think about it, that's R, the revenue per computer code reading. So what we're saying here is that the quantity to break even is 200. It's got to break even by the time they read 200. All right, well, the quantity to break even, what is it? It is, from above, 65,000. We don't know what the revenue is, but the variable cost is still 10. I'm just actually restating what I wrote before. The quantity to break even has to equal 200. Solve for R. That will tell us what we need to charge. Okay, so it's just a little bit of algebra here. That means that 65,000 equals 200 times R minus 10, or the revenue per unit minus 10 equals, I could divide both sides by 200. I did that in my notes and I get 325. 65,000 divided by 200. Oh, and then I can add 10 to both sides. There it is. 335. I have solved for R. That is a price. That is the answer to the question right there. If AutoShop wants to break even by the time they read the 200th car engine, they're going to have to charge $335 per reading, which is considerably more than they were considering at the beginning of this question.